Here's one of our favorite tools called Orange. Orange is a nice desktop application that contains a lot of widgets to manipulate data, to visualize data, to model data. You can get the desktop application from the address you see here on the screen, orange.biolab.si. Once you have it installed, the first thing to do is to go to your Data tab, grab the File widget and drop it on the canvas. Double-click that File widget and you'll get a dialog that allows you to pick some data. Now here I've already preloaded this set of data called house data. It's a text file or tab file. So tab delimited files are what Orange uses. And of course there's a dialog to pick other files. So now let's take a look at that data by dragging a data table onto the canvas here, and simply where it's has a check mark line, a dashed line, you can drag a connection between the file and the data table. You'll notice you cannot see the data in the file until you have some way of visualizing that. So here's a data table now, and it's feeding, the file is feeding its data to the data table, and we can see that. Now, the reason to bring this up is to show both the variables, and we're going to model this in a minute, but also the important aspect that almost all the models in Orange assume you will use all the independent variables, and the dependent variable must be the last column in your data set. So I'm going to try to prove the price of a house by looking at square footage, bedrooms, bathrooms, acreage, whether a pool or not is present. And then you see the price of the house over here. Very simple data set. The important thing, most of the time I put the independent variable on the left. For Orange it must be the last on the right, the last column on the right. So there's no ability to specify independent and dependent variables. It just assumes the last one on the right is the independent variable. Okay, let's just move that out of the way a little, and then we'll have the file. And we can also, there's visualization widgets like this, where you can, where you can connect like this and begin to look at the data here, manipulate these in different ways. Very, very useful. Let's get this out of the way. Now let's do a simple regression. As we know, this is a straightforward data set. If you recall looking here at the data, this is a continuous variable. This is numerical but categorical. Same here. So number of bedrooms. Sorry, this is continuous. So this is continuous. So is acreage. Pool is discontinuous or categorical between a yes or no in the presence of the data. The presence of a pool, yes or no. So we drop the linear regression widget on the pane, and then we can connect that as well. Now there'll be some choices in any model. We'll leave these as the default. One of the things you'll always have to do, just like we connected the data table or distribution to the file, is you must also connect what's called a test learner under the evaluation tab, because you won't see the results of this until you pull this together. The other thing you have to do is connect the data to it. And so you have to feed the data over to the test learner as well as the model, otherwise you won't see any result. And when we do that, suddenly we can see an R-squared figure here for this linear regression, which is 0.9, pretty high. There are other versions of R-squared here, but we're sticking with the traditional R-squared, easy on a 0 to 1 scale. You have some other choices to look in terms of random sampling, leave one out, cross-validation. You can change some parameters, and it will update automatically. You can see that both up here as well as over here as the graphic shows things are moving in our to update. You can finally you can also use a for more advanced models you can use a confusion matrix and some predictors and other things like that, so you can connect things here sorry, not this particular model because we're not using a training set, but you test it, you predict it, you get a confusion matrix or a good versus bad prediction matrix, if you will. Those are possibilities. But then you can also utilize some of these other models. So what's nice about this environment is you can begin to pull these together quickly, oops, excuse me, and connect them together and see, oops, didn't like that one, I'll find out why. Pull those together and take a look. Yeah, something's wrong with those other models. Let's see. Here's a support vector machine. Looks like I have some updating to do on some back-end material, but in any case, you'll see at the end you should be able to see the various methods and their R-squared, so you can do some comparison among all these different different models. So that's Orange in a nutshell.